Graph y equals negative x squared. Well, what we can do to figure this out is we know that regular x squared is a parabola that looks like this. So graphing y equals negative x squared is going to be the same thing but upside down. Now, if you need a few variables or a few values, that's fine. Let's write out a few. Let's write out, since this happens at the middle, let's just write out maybe 3 of them. Or now we'll do 4. We'll do -2, -1, 0, 1, 2. So we'll see what happens when we plug in x and what y we get. So I get -2 squared, right? So -2 squared, which is -4, right? So -4, bloop. This would be -1 squared, so -1, which is -1. -0 squared, which is -0, which is 0. -1 squared, which is -1 squared, which is -1. It's -1. It's -1. And -2 squared, which is -4, which is -4. So we have a few points now. Okay? -2, -4, put a dot right there. -1, -1, put a dot right there. 0, 0, put a dot right there. 1, -1, put a dot right there. And 2, -4, put a dot right there. Now this is an inequality, right? And the inequality that we're given is greater than or equal to. So one thing we have to remember is when we draw our graph out, when we draw our curve, it's going to be a dashed line, like so. Okay? And not only that, we also care about everything above. Since it's greater than, there's going to be shading. So we're going to shade above the curve, not inside the curve, above the curve. So everything that I'm shading is technically a correct solution to this inequality. Like if I were to choose 2, 1 here and plug in 2, 1, it would give me a correct solution because of the fact that it's an inequality, and I don't care about things being equal. In this case, I care about things being greater than. I'm not allowed to include the line itself. The line doesn't count, but everything in the shading does. And that's how you graph a parabola. That's an inequality. Graph y is greater than or equal to x squared minus 6x plus 13. In order for us to do this problem, what we really need to do is find out where the center of this parabola is going to exist. Okay, so the way we figure that out is we label this invisible A, B, and C. The center is going to exist at the x value of -b over 2a. So the center of this is going to be at -6 over 2 times invisible 1. Okay, because a is invisible 1. So the double negative makes a positive. 6 over 2 is 3. So I now know that I can make a nice little table, and 3 can be the center of it. So let's do 2, 1, let's do 4, 5, and start plugging things in, which is not going to be the most pleasant thing on the planet. Okay? Well, let's just do it though. All right, so we have 1 squared minus 6 times 1 plus 13. 1 squared is 1. 6 times 1 is -6. And then you have plus 13, and that's going to end up being 8. 2 is going to be 2 squared minus 6 times 2 plus 13. 4 minus 12 plus 13 is going to be 5. 3 squared minus 6 times 3 plus 13 is going to be 9 minus 18 plus 13, which is going to be 3. 4 squared minus 6 times 4 plus 13 is going to equal 16 minus 24 plus 13, which is 5. And last but not least, 5 squared minus 6 times 5 plus 13 equals 25 minus 30 plus 13, which equals 8. So we have our points. Okay, 1, 8 is a point. 2, 5 is a point. 3, 3 is a point. 4, 5 is a point. And 5, 8 is a point. Now, this is greater than or equal to. Okay, that's thing number one that we haven't even done like the heavy duty part of the graph yet. We just put dots there. That's greater than or equal to. The or equal to part says that we are going to make a solid graph like so. I could have done a much better job drawing that out. Made it more curvy looking. I did it again. That just looks awful. Part 2 is the fact that it's greater than, which means what we're going to do is focus on shading above the line, which happens to be inside the graph, inside the parabola looking part, like that. So what this means is anything on the blue line and anything that's shaded there in purple is a solution to this inequality right here. So it's not so much picking points and graphing the points. You have to remember to do some solid or dashed lines and some shading as well. Solve a squared equals 4. Let me write this out and give myself a little bit of space. Now, a squared means a is not all by itself. So in order to solve a squared problem where the variable is squared, you square root both sides. Now this is what you have to remember. When you square root both sides to solve for a variable, you have to attach a plus or minus to the other side. So a is just not going to be 2. A is going to be positive or negative 2, which makes sense because if I take 2 and square it, I get 4. If I take negative 2 and multiply that to itself, I also get 4. So a is going to equal positive or negative 2 in this case. Solve 2m squared plus 10 equals 210. Let's get m all by itself. First, let's subtract 10 from both sides, like so. 2m squared is now going to equal 200. Let's divide both sides by 2, and m squared will equal regular 100. Now, in order to get m all by itself, you have to square root both sides. In order to square root both sides, we have to make sure that we attach a positive or negative symbol to the other side. Always do that. So that's going to leave you with m equals not 10, but positive or negative 10. Solve a plus 1 in parentheses times a plus 2 in parentheses equals 0. This is going to use a little guy called the zero product property. The zero product property says if you have something times something equals b, then you set each something equal to 0, each of them. So what we do is we set each parentheses equal to 0 and solve. So you subtract 1, and a is going to be negative 1. Subtract 2, and a is going to be negative 2. So I have two possible answers, negative 1 and negative 2. Now you might be noticing, oh, it's basically just the opposite. That's correct. When your factors are just the variable plus or minus just a number, it's going to be the opposite. It gets a little hairy when you start adding numbers in front of the a, when you start making coefficients, but that didn't happen here. Solve 2m plus 3 in parentheses times 4m plus 3 in parentheses. Whenever you have something times something equals 0, you're going to use what's called the zero product property. The zero product property says if you have this times that equals 0, then you set the first factor equal to 0 and the second factor equal to 0 and solve for both. So, in this case, 2m plus 3 equals 0 and 4m plus 3 equals 0. Let's solve. minus 3, cross you out, drop down to m equals negative 3. Divide by 2, cross you out, m equals negative 3 over 2. That's one of my answers. Let's do that again. We've got minus 3, cross you out, drop down to 4m equals negative 3, divide by 4, cross you out, and m equals negative 3 over 4. So I have two answers, and my two answers are m equals negative 3 over 2 and negative 3 over 4. Zero product property, fun stuff. Solve n squared plus 7n plus 15 equals 5. Whenever we have something that is a quadratic and something that looks factorable, what we want to do is set it equal to 0. So let's subtract 5 from both sides. N squared plus 7n plus 10 equals 0. Now you can factor this. There's two numbers that you can add to get 7 and multiply out to get 10. So that can factor out to n plus 2, n plus 5 equals 0. Now we use what's called the zero product property. The zero product property states that a times b equals 0. And if a times b equals 0, then a equals 0 and b equals 0. What does that mean here? Well, you would be like an A and you would be like a B, so n plus 2 equals 0 and n plus 5 equals 0. Subtract 2 from both sides for that first one, n equals negative 2. So basically, since we had n plus 5, it's just the opposite. And subtract 5 from you, and that's going to be n equals negative 5, basically the opposite. So at the end of the day, I have two answers. N equals negative 2 and n equals negative 5. And that's it. Solve 6n squared minus 18n minus 18 equals 6. Well, this is a quadratic, and what I really want to do when I'm solving quadratics is to try to get it equal to 0. So let's subtract 6 from both sides like so. 6n squared minus 18n minus 24 equals 0. Now that looks like I can rip out a 6. So let's do that. Pull a 6 out, and you have 6 times the quantity n squared minus 3n minus 4 equals 0. The 6 stays there. N squared minus 3n minus 4 factors out to n minus 4n plus 1. Now, this is going to use what's called the zero product property. The zero product property says if you have a times b equals 0, you can set each thing equal to 0 and solve for the variable. All right, so I have three things here that I can set equal to 0. 6 is equal to 0, n minus 4 is equal to 0, n plus 1 is equal to 0. 6 equals 0? That doesn't make sense. Add 4 to both sides. So n will equal 4, minus 1 from both sides, so n equals negative 1. So I only have two answers here. Since there was no n attached to that 6, there's nothing that's going to happen with that 6. It's just there. That's why we crossed it out. This n minus 4 gives me its opposite, which is 4, and n plus 1 gives me its opposite, which is n equals negative 1. And so we have two answers, 4 and negative 1. Solve using the quadratic formula. The quadratic formula is this wonderful little formula that you can use to solve any quadratic, and it goes a little something like this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. You're welcome for singing. What's my A? U is. What's my B? U is. And what's my C? U is. So now it's a matter of plugging stuff in and doing some ugly looking math. So negative B is going to be negative 3 plus or minus the square root of B squared, which is going to be negative 3 squared minus 4 times A, which is 2, times C, which is negative 5, all over 2 times a, which is 2. Negative negative 3 is 3, plus or minus. Inside the square root, I have negative 3 squared, which is 9, minus 4 times 2 times negative 5 is going to be plus 40, all over 4. That is nice. That becomes 3 plus or minus the square root of 49, all over 4. The square root of 49 is 7. So I have 3 plus or minus 7 over 4. Once I get to that point, I can split this up into two different problems. 3 plus 7 over 4 and 3 minus 7 over 4. 3 plus 7 over 4 is 10 over 4, which is 5 over 2, or 2.5. And 3 minus 7 over 4 is negative 4 over 4, which is negative 1. Okay, so my two answers are going to be x equals 5 over 2 and negative 1. That's quadratic formula. Solve using the quadratic formula. Well, before we can even use the quadratic formula, we have to make sure that this is equal to 0. So let's add 10 to both sides. And by doing so, we get 2m squared minus 7m minus 3 equals 0. Now we can use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Bump. So what's a, b, and c? Your a. B is negative 7, and c is negative 3. So now it's a matter of plugging stuff in. X equals negative b is negative negative 7, plus or minus negative 7 squared, because it's b squared, minus 4 times 2 times negative 3 all over 2 times a, which is 2 times 2. Let's simplify. Negative negative 7 is 7, plus or minus negative 7 squared is 49, minus 4 times 2 minus 3, or times negative 3, is going to be plus 8 times 3 is 24, all over 4. That becomes 7 plus or minus the square root of 73 all over 4. Now, you can't do anything with the square root of 73 unless you plug it into a calculator. So most teachers would say, you know what? Leave it like that. You're done. Now, you might have a teacher that'll ask you to find out what the square root of 73 is and, keep going. But this to me is perfectly acceptable, so this to me is going to be my answer. Solve 15a squared minus 3a equals 3 minus 7a. Well, in order to solve this type of quadratic, we need to move everything to one side of the equal sign and set it equal to 0. Then factor. So, let's add 7a to both sides. Add 7a to both sides. Let's scooch all this stuff over here. 15a squared minus, plus 4a is now equal to 3. Let's subtract 3 from both sides. Minus 3, cross u out. That gets me 15a squared plus 4a minus 3 equals 0. Now, this is one of those frustrating factoring combination type problems where what we really need to do is list out all of our possible options that we can get and try to come up with some type of combination that allows us to factor and turn that into 15a squared plus 4a minus 3. Then we're not even done yet. But I know that if I multiply like 1 to 15 or 3 to 5, that'll get me 15. The negative 3 is kind of the more pain in the butt, where I could have negative 3 times 1, or 3 times negative 1, or negative 1 times 3, or 1 times negative 3. Those are our options, right? And so I need to come up with a combination that gives me something that looks like this. And sometimes it's trial and error, and even now I'm trying to look at this and talk it through in my head. and see if I can figure it out on the fly. And as you can see, I am kind of struggling, but maybe it's you. Where if I were to take, maybe not you, because I can't pull the 3 out. So maybe it's you that should work. No, it would be, well, hold on. Let's try this. Let's try the 3a and the 5a. If I multiplied 3 to negative 1, that gets me negative 1, and that's 15. So this one won't do it. That's not the combination that I want. So the combination that I want is probably going to be that one. 3 times 3 on the outside is going to get me 9. 5 times negative 1 on the inside is going to get me 4. So this is the guy that I want. So this is the combination that I want, this one right here. So that's a 3a and a 5 minus 1 right here and plus 3 right here. So the tricky part is coming up with a combination that allows you to factor all this out and get you exactly what you want. That's the tricky part. This part's not so bad because now I use zero product property, which states that if you have something times something equals 0, you set each something equal to 0. So 3a minus 1 equals 0, 5a plus 3 equals 0. And then you solve each for a. Okay, add 1, 3a equals 1, divide by 3, a equals 1/3. So that's option number 1. Minus 3, cross you out. 5a equals negative 3, divide by 5, cross you out. A equals negative 3 over 5. So my two possible answers are a equals 1/3 and negative 3/5. And there you have it. Solve using the quadratic formula. All right, well, in order to solve using the quadratic formula, I need to make sure that everything is on one side of the equal sign. So what I need to do first, before I do anything, is subtract 9n to get rid of u, and subtract 4 to get rid of u. So let me write that over here so it's a little out of the way. 9n squared minus 7n minus 4 equals 0. Okay, now the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a, like that. U would be my a, u would be my b, and u would be my c. Okay, and then you just plug and chug. X equals negative 7 plus or minus the square root of 7 squared minus 4 times 9 times negative 4 all over 2 times 9. Now it's just going to be a terrible, gross-looking PEMDAS problem. Negative 7 is positive 7, plus or minus. The square root of 7 squared is 49. We've got negative 4 times 9 is negative 36, and negative 36 times negative 4 is 144. And that's going to be all over 18. 7 plus or minus 49 plus 144 is 193. Not much you can do with that. Not much at all that you can do with that. So since that's kind of like we're at a stalemate, there's nothing I can do with that number. You can't take the square root of 193 without it being a terrible, irrational number. Since that's the case, we're going to leave it like that. And some teachers might have you, find out what that is as a decimal. I don't want to. That's kind of never been my thing, so I'm going to leave it like this. But yeah, that's as unpleasant as the answer appears. That's really how it ends. That's it. Solve by completing the square. Whenever you solve anything by completing the square, you have to make sure there's nothing in front of your squared term. Since there isn't in this case, we can move on to step 2. Step 2 is get rid of the constant on the left by doing whatever to both sides. So I need to add 48 to both sides, add 48 to both sides. So now I have a squared minus 2a equals 48. Now I have this space here because the next step is going to be weird. Take half the number in front of a. So in my mind I'm thinking, all right, half the number in front of a is going to be -1. Square that, which becomes +1, and add that number to both sides. Okay, so now I have a squared minus 2a plus 1. The point of this is so that you can factor that using a perfect square trinomial. This now factors to a minus 1 squared equals 48 plus 1, which is 49. Okay, that's the goal. Now that we have something squared equals a number, square root both sides, and don't forget your positive or negative. Okay, this cancels out, and you're left with a plus 1 equals positive or negative the square root of 49, which is 7. Now what I can do is I can take that guy and say, all right, well, it looks like we have two equations going on here. I have a minus 1 equals positive 7, and I have a minus 1 equals negative 7. If I add 1 to both sides, that gets me a equals 8 for one option, and if I add 1 to both sides over here, that gets me a equals -6 for the other option. So my two possible answers are going to be a equals 8 and -6. And that is how you do completing the square. Solve by completing the square. You've got m squared plus 10m plus 14 equals -7. First thing you want to do when you complete the square is make sure there's nothing in front of your square function. There isn't. The second thing you want to do is make sure that the constant living on the left side is moved to the other side. So we're going to subtract 14 from both sides, like so. Now we have m squared plus 10m equals -21. Now, next step is I have to take the number in front of m. That's why I left the space here. I have to take the number in front of m, take half of it, which becomes 5, square that, which becomes 25, and add that to both sides. Now, what that does for me on the left is that gives me a perfect square trinomial, like this, where I know m plus 10m plus 25 factors out to m plus 5 squared. That's going to equal what we get over here, -21 plus 25, which is 4. So you're going to square root both sides. Don't forget to attach the positive or negative when you square root that side. The square and the square root cancel each other out, leaving you with m plus 5 equals positive or negative the square root of 4, which is positive or -2. Okay, now what we have is two math problems going on here. We have m plus 5 equals 2, and we have m plus 5 equals -2. Subtract 5 from both sides. Subtract 5 from both sides. M equals -3. Subtract 5 from both sides. And m equals -7. So at the end of the day, we have two possible answers. M equals -3 and -7. And that's your guy. Solve by completing the square. The first thing you want to do when solving by completing the square is make sure there's nothing in front of n squared. And since there is, we have to divide everything by 2. Everything by 2. So you become n squared, you become 6n, you become 5, and you still stay at 0. The second thing we need to do is get rid of the constant on the left. So subtract 5 and subtract 5. Now we have n squared plus 6n equals -5. Now that we have all those things changed and moved, take half the number in front of n, which is 3, square that, which is 9, and add that to both sides. So plus 9 and plus 9. That leaves us with n squared plus 6n plus 9, which is always going to be a perfect square trinomial. So it factors out quite nicely to that. And that's going to equal negative 5 plus 9, which is 4. Now that we have something squared equals 4, we can square root both sides. And when you square root both sides, don't forget the positive or negative, so that cancels out. And let's move it up here. Now you're left with n plus 3 equals positive or negative the square root of 4, which is 2. We could take that and split that into two different problems. N plus 3 equals positive 2, and n plus 3 equals negative 2. Subtract 3 from both sides, subtract 3 from both sides, n equals negative 1. Subtract 3 from both sides, subtract 3 from both sides, and n equals negative 5. So that gives me two potential answers, n equals negative 1 and negative 5. And that's completing the square.